In a military world dominated by billion-dollar fighter jets and nuclear-powered aircraft carriers, there is a single weapon that costs only a few $1,000s, but can stop entire navies in their tracks. It has no sophisticated radar, no pilot, and can lie in wait in the darkness of the ocean for decades without making a sound. When a sea mine is first planted in a body of water, the calculus of war changes instantly. Enemies are no longer fighting just warships. They are fighting the fear of something invisible. It's not just about explosions. It's about controlling access to the sea and destroying an enemy's economy without firing a single shot. This is the story of the sea mine, the most effective asymmetric weapon ever invented by mankind. The evolution of naval mines is a record of human ingenuity in creating traps. From wooden boxes filled with gunpowder in the 14th century to today's ingenious torpedoes, the basic principle remains the same: exploiting a ship's structural weaknesses. Why are naval mines so deadly? The answer lies in the physics of water. Unlike air, which can be compressed, water is nearly incompressible. When a mine explodes beneath a ship's hull, all the energy of the explosion is transmitted directly through the water in the form of a powerful shock wave. However, the real threat is often not the direct explosion, but rather a phenomenon called the bubble jet effect. When a mine explodes, it creates a giant gas bubble that expands and deflates within milliseconds. When this bubble collapses beneath the ship, it creates a highly pressurized water flow capable of lifting the ship upward and fracturing its backbone. A 1,000-ton warship can be split in two by a single, well-placed mine. The trigger mechanism has also evolved beyond simple physical contact. Modern mines are equipped with multiple sensors: magnetic to detect steel hulls, acoustic to detect propeller noise, and pressure sensors to detect water displacement from large vessels. The most terrifying is the ship counter system. This program allows the mine to let the first or second ship pass, usually a minesweeper, and only detonate when a third ship, a primary target such as an aircraft carrier or a logistics ship, passes directly overhead. The deployment of naval mines is a form of asymmetric warfare. The cost of producing a single mine is only about 0.5% to 10% of the cost to the enemy to defuse it. Tactically, mines are classified based on how they are deployed on the battlefield. Anchor mines are the most common, attached to weights on the seabed, and floated at a specific depth to target the hulls of large ships. An automated placement system using plummets ensures these mines are placed at precise depths without the need for time-consuming manual measurements. In deeper waters, we're familiar with bottom mines that burrow into the mud, making them nearly impossible to detect with conventional sonar. However, the pinnacle of this technology is capsule mines, like the Captor, capsulated torpedo. These are no longer passive mines, they're automated torpedo launchers. They detect the acoustic signature of an enemy submarine, open their shells, and launch active torpedoes that pursue their targets until they're destroyed. This transforms mines from mere obstacles into active hunters. Their ease of deployment poses a major threat to international law. Mines can be dropped from aircraft, launched from submarine torpedo tubes, or clandestinely planted by disguised civilian cargo ships. In modern conflicts, drifting mines are often used. Although banned by the Hague Convention as a danger to civilian navigation, these mines are often used as weapons of terror to block vital trade routes such as the Red Sea or the Strait of Hormuz, creating a global economic crisis with just a few explosive-filled iron balls. Clearing a minefield is one of the most dangerous and time-consuming operations in naval warfare. It takes about 200 times longer to defuse a mine than it does to set it. Minesweepers must be constructed of non-magnetic materials, such as wood or fiberglass, to avoid triggering magnetic mine sensors. However, as mine technology advances, using composite materials and anechoic coatings, traditional sonar is losing its effectiveness. Clearance methods are now shifting to autonomous technology. Unmanned underwater vehicles, UUVs, are used to identify and destroy mines without endangering human life. Beyond technology, some militaries are even training marine mammals like bottlenose dolphins, as their natural sonar capabilities are far more accurate at distinguishing metal objects on the muddy seabed. However, smart technology on naval mines is always a step ahead. They are now programmed to detect the sound patterns of minesweepers and remain silent until the actual target vessel passes by. The long-term risk of sea mines lies in their status as perpetual weapons. Thousands of mines from World Wars I and II are still found today in the North Sea and the Pacific. Mines planted without clearly recorded coordinates, especially by non-state actors, will pose a threat to civilian shipping for decades after the conflict ends. In the future, our challenge will not only be how to destroy these mines, but how to prevent these asymmetric weapons from falling into the wrong hands amidst escalating global geopolitical tensions. Sea mines are a reminder that in war, even the simplest technology can be the most deadly if used strategically. They are weapons that force the enemy to pause, think, and ultimately surrender to uncertainty. In a world increasingly connected by sea, these subsurface threats remain a persistent specter. Understanding how they work is not just a military matter, but a matter of understanding how fragile the stability of our world is when faced with unseen traps.